All right. In this video, we're going to go over reflections across the X and Y axis and its definition. And then we're going to use what we did in the previous two videos as well as this video. And then we're going to answer the next question in its own separate video. Okay. Reflections over the X and Y axis. And this has a lot to do with the notation for even and odd. Because if you look here, these are notations for even and odd functions. So that's something to do with reflections. Anyways, we know that y is the parent function. Y equals f of x is the parent function. And it says let y equal g of x is f of x reflected. So we know function g is function f being reflected. But how is it being reflected? There are two ways it can be reflected. Now notice, when we have a reflection, there's some sort of negative sign involved. So for the first one, it says g of x equals f of negative x is a reflection of y equals f of x about the blank axis. Change the sign for every blank coordinate. So f of negative x is a reflection across some axes. And when you reflect across that axis, you're also supposed to change the sign of the blank coordinate. But then number two, if you notice, the negative sign is being multiplied to the function. And this is saying that this is also a reflection about blank axis. And then you change the sign of blank coordinates. So once again, you have two different scenarios. Or you can have three if you have, well, technically you can have four, but the two scenarios in this case, either the negative is inside the parentheses or the negative is outside the parentheses. Either the negative is multiplied to the x or the negative is multiplied to the entire function. All right, so it says sketch the graph of each and function in a different color. Write the transformations in words. And the parent function is the square root of x. And we should know for the square root of x, we're going to use specific numbers, which is 0, 1, 4, 9, and 16, but there's no 16 here. And that's the shape of the graph. The first one says g of x equals negative f of x. So in this first case, the negative is on the outside of the function, whereas the second one, the negative is inside the function. Let's see how those things work. So I'm going to choose my basic numbers. Well, 0, 1, 4, and 9. Because those are all perfect squares. Well, if x is 0, then the output is going to be negative square root of 0. And that's just 0. Because 0 is neither negative nor positive. So that's the point 0, 0. That's already plotted, so I guess I can put that in black. No, I'll put that in blue, actually, in this case, because I'm trying to make a point. So the next one is going to be 1. So that's negative square root of 1. And we know the square root of 1 is just 1, so that's going to be negative 1. So our point, well, I guess I'll write it. The point is going to be, well, x is 1 and the y is negative 1. That's the point of 1, negative 1. And that's going to be down here. Now, if you notice, the points are in the same position for the x, but the y values are changing. The y values have different signs. Let's do one more before we make some sort of generalization. Let's now try to find, when x is 4, what is g of x? That's going to be the square root of negative 4. Keep the negative on the outside, and the square root of 4 is 2. So that's -2. So the point is going to be 4, comma, -2. And you're going to plot that point. So then by assumption, I'm going to say the next point is going to be 9, comma, -3. And that should make sense. Negative square root of 9. Square root of 9 is 3, so that's going to be -3. 0.9, comma, -3. X is 9, y is -3. And we're going to sketch that function. And that is the function g of x equals negative square root of x. And as we can see, that is a reflection across the x-axis. So f is reflected across, can't spell across, x-axis. So when a negative is outside the function, that is reflection across the x-axis. And if you notice, when you reflect across the x-axis, change y value sign. Every y value, every y coordinate changed its sign. So I'm going to highlight the most important part of that statement. When you reflect across, rather, when there's a negative in front of the function, you are going to reflect across the x-axis. When you reflect across the x-axis, you change the sign of every y coordinate. Okay. Now we want to sketch h of x. H of x equals to the square root of -x. I'm going to do this one a little bit backwards in this case. And you're going to, hopefully you can understand why I'm doing this one backwards. If I look at the last problems, the y values were -1, -2, -3. I'm going to go to the original function. They have y values rather of 0, 1, 2, and 3. So I'm going to start here. Let's start at 3 equals to the square root of 9. Because we know that the square root of 9 is 3. And in this case, 3 is the y value. 3 is not the x. 3 is the y value. So matter of fact, let me write like this. I'm going to go backwards. 3 is equal to the square root of 9. But we can rewrite this square root of 9 as the square root of -9. I don't want to use blue. Let's use red. Or let's use green, actually. -9. And for that to happen, that means x has to be -9. In this case, x has to be -9 because it's square root of -x. Which means the x is already negative. Go back to the definition. In the first one, the x is already negative. So that means by default, you're changing the sign of every x coordinate. So that's going to be the point. I'm going to go down here. Point of -9, 3. -9, 3. That is on the far side of the quadrant 2. In relation to the parent function, the y value stayed the same, but then the x value changed its sign. So we changed the sign of every x coordinate. That's a reflection about the y-axis. I'll put that there for right now, and let's just verify that's true. Let's do one more. instead of using +4 like I did in the first one, I'm going to use -4. So -4 is x, and to find our y, that's going to be negative of -4 under the square root. 2 negatives makes a positive, so it's going to be the square root of 4, and the square root of 4 is 2. That's going to be the point of -4, 2. X is -4, y is 2. Plot that there. And as you can see, we reflect it across the y-axis. So therefore, the negative point, the next point would be -1, 1. And don't forget we have that 0, 0, which I'll put like that. And then we'll sketch that. H of x equals to the square root of -x. And because of the negative for the x changes its sign. When the x changes its sign, it's a reflection across the y-axis. Let's highlight that part. Negative inside the parentheses, reflect across the y-axis. Negative outside the parentheses, reflection across the x-axis. So let's just fill that in. I don't know if you hear that in the background. That is the police. Welcome to New York City. Okay. F is reflected. Across y-axis. Change the sign of every x. All right. That is it for this video on reflections. Hopefully that was helpful. The definitions are the most important part. I'm just using some parent functions for us to make the sketch. The next video, we're going to combine some vertical shifts, horizontal shifts, and reflections. And that's going to be a final exam question. See you soon.